A video for chapter 5, section 2, which is called graphing polynomial functions. In terms of this, we're going to graph, and basically what this chapter is pretty short. It's only got 2 example problems. I'm going to go through one. The second example problem is done the same way. And basically what we're doing is going through everything that we learned in section 1. So it's asking us to graph f of x equals 2x plus 1 in parentheses to the first power. And normally there's nothing there. I just put the 1 there to remind me it's to the first power. And then we have times x minus 3 to the second power. Now, one of the things you can do is you can always take factors and look at their exponential powers and know that this polynomial is going to be to the 3rd degree. So the first thing we're going to do is we're going to take each one of those factors, the 2x plus 1, subtract the 1, divide by 2, we get an x-intercept of negative 1/2, 0, which we plot on the graph there. Then we're going to take the x minus 3, set it equal to 0, solve, we get a 0, or an x-intercept of 3, 0, which we plot right there. Then what we're going to do is we're going to take and multiply this whole polynomial out. So what I did first was multiply x minus 3 times x minus 3. I get x squared minus 6x plus 9. Then I multiply by 2x plus 1. And I get this final polynomial, expanded polynomial, of 2x cubed minus 11x squared plus 12x plus 9. If I want to find my y-intercept, all I'm doing is plug in 0 in for the x's. So this becomes 0, 0, 0, leaves me a 9. So my y-intercept is 0, 9. And I plotted 0, 9 right there as a y-intercept. So this is a way that you can get 3 points on any graph that you do by using the factors to find your x-intercepts, then multiplying it out, plugging 0 in, whatever your constant is, that's your y-intercept. So now what we do is we go to what we call end behavior, which we got in section 1. And if we know our 4 rules of end behavior, what we're doing is we're looking at this first term. Because the exponent is odd, but the coefficient is positive, that's telling us that the left side goes down, the right side goes up. That's one of your 4 rules. You got to know those 4 rules. Okay? Then we go to multiplicity. Multiplicity was telling us what happens at the zeros. Remember, if I have a multiplicity where the exponent is odd, like this one here, then that means the graph is going to pass through that x-intercept. If I have a multiplicity that's even, which is like this 2, then that means the graph is going to go up, or come down in this case, come down, touch the 0, and then go back up. It doesn't pass through. And so now, just by using those rules, I can connect the lines, and if I connect the lines here, and then I connect this line coming down here, and this one here, I have my final graph of this particular polynomial. Notice also, when we come down here, because the highest degree is 3, if I subtract 1 from that, I should have 2 turns. So as the graph comes up here, here's a turn. The graph comes down here, here's a turn. So I've got the right graph. If you want to look on page 347, they have graphed it the same way. Much better graphs than mine, but following the same procedure. So whenever you're graphing polynomials, you always want to find your x-intercepts and your y-intercept. You want to plot those points. And then what you want to do is find your end behavior and your multiplicity. And from that, you may have to plug in points in between to find out what the graph's doing, but a lot of times you can just draw a general sketch of the graph.